In this video, we'll talk about the sum and difference identities for sine and cosine. The sum and difference formulas, or sum and difference identities for sine and cosine, are what you see here. We let alpha and beta be any angles. Then sine of alpha plus beta is sine of alpha times cosine of beta plus sine of beta times cosine of alpha. Sine of alpha minus beta, the difference formula, is sine of alpha times cosine beta minus sine of beta times cosine of alpha. So what you'll notice is that you start with sine of alpha plus beta, or sine of alpha minus beta, and you end up with a product of sine and cosine plus sine and cosine, or sine and cosine minus sine and cosine. So the sum formula gives you a plus, and the difference formula gives you a minus. So the sine function preserves the sign, whether it's plus or minus. Notice also that you have sine of the first angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. So you have all of the combinations here of sine and cosine with the two angles. That's the sum formula. The difference formula is exactly the same, but it just changes the plus sign into a minus sign. These are the sum and difference formulas for sine. We also have sum and difference formulas for cosine. Cosine of alpha plus beta is cosine of alpha times cosine of beta minus sine of beta times sine of alpha. The difference formula is cosine of alpha minus beta equals cosine of alpha times cosine of beta plus sine of beta times sine of alpha. So for the sum formula, the plus is turned into a minus, and for the difference formula, the minus is turned into a plus. For the cosine formulas, notice that we have cosine of alpha times cosine of beta minus sine of beta sine of alpha. So in this case, you're looking at a product of two cosines and a product of two sines. The plus becomes a minus, and the minus becomes a plus. Cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of beta sine of alpha. Cosine of alpha minus beta is the product of the two cosines, cosine alpha, cosine beta, and then plus sine of beta sine alpha. Let's do some examples where we use the sum and difference formulas for sine and cosine to compute various values. For our first example, let's find the exact value of cosine of 75 degrees. We're going to use a sum or a difference formula. In this case, we're going to use the sum formula because we're going to use the fact that 75 degrees is equal to 45 degrees plus 30 degrees. So in other words, cosine of 75 degrees is equal to cosine of 45 degrees plus 30 degrees. So here we have a cosine of a sum of two different angles. So we're going to use the sum formula for cosine. That will be cosine of 45 degrees times cosine of 30 degrees. And cosine is the one that turns the plus into the minus sign. And then it will be sine of 45 degrees times sine of 30 degrees. It's the product of the two cosines minus the product of the two sines. Now each of these we can compute. Cosine of 45 degrees, that's the square root of 2 over 2. Sine of 45 degrees is also square root of 2 over 2. What about cosine of 30 degrees? If you're not sure, it might help to draw a little unit circle, like so. So 30 degrees is the same as pi over 6. So this is 30 degrees. And 30 degrees is pi over 6 radians. So this point right here has a larger x value than a y value. So it's going to be square root of 3 over 2, comma 1/2. If it was 60 degrees, or pi over 3 radians, that would be reversed. So cosine of 30 is the x-coordinate, so that's square root of 3 over 2. And then sine of 30 degrees, that's the y-coordinate, so that's 1/2. And that is equal to the square root of 2 times the square root of 3, which is the square root of 6, over 2 times 2, which is 4, minus the square root of 2 times 1, divided by 2 times 2, which is 4. So we end up with the square root of 6 minus the square root of 2, all divided by 4. For our next example, we'll find the exact value of sine of 15 degrees. And we're again going to do this using a sum or difference formula, this time for sine. And actually we're going to use the difference formula in this case, because 15 degrees is 45 degrees minus 30 degrees. So sine of 15 degrees is equal to sine of 45 degrees minus 30 degrees. So we want to use the difference formula for sine. So that's going to be sine of 45 degrees times cosine of 30 degrees. And now sine preserves the sign, so this is still going to be a minus sign. Now it's going to be sine of the other angle, which is 30 degrees, times cosine of the other angle, which is 45 degrees. Okay, what are these values? Well, sine of 45 degrees, that's square root of 2 over 2. Cosine of 45 degrees, that's square root of 2 over 2. Cosine of 30 degrees, we just figured that out on the previous slide, and that was square root of 3 over 2. And sine of 30 degrees, that's 1/2. So we end up with the square root of 2 over 2 times the square root of 3 over 2, which is the square root of 6 over 2 times 2, which is 4, minus 1/2 times the square root of 2 over 2, which is the square root of 2 over 4. And that is the square root of 6 minus the square root of 2 over 4. Now you might notice that that's actually the same value that we saw on the last example, and that's not a coincidence. 15 degrees and 75 degrees are complementary angles. So note that 15 degrees plus 75 degrees is equal to 90 degrees. So these are two complementary angles. So cosine of 75 degrees is equal to sine of the complementary angle, which is what we just computed. And cosine of 75 degrees is what we computed in the previous example. So these two are equal to each other by the cofunction identity. Cosine of 75 degrees is equal to sine of the complementary angle. So it's not a coincidence that these two examples gave us the same answer. Let's do another example. This time, let's do things in radians. So now we want to do sine of 7 pi over 12. In order to use a sum or difference formula, we need to write this as the sum or difference of some other angles that we already know how to compute sine and cosine for. So in this case, we're going to write this as sine of 3 pi over 12 plus 4 pi over 12. How does that help us? Well, if you reduce these fractions, this is sine of pi over 4 plus pi over 3. And we know how to compute sine and cosine at the angles pi over 4 and pi over 3. So we're going to use the sum formula for sine. So the sum formula for sine tells us that sine of pi over 4 plus pi over 3 is sine of pi over 4 times cosine of pi over 3. And sine preserves the sign, so it's a plus, so you have a plus here. And now it's just going to be sine of the other angle, pi over 3, times cosine of the other angle, which is pi over 4. Now when I say the other angle, I mean other than the one that we just did. So the first product was sine of pi over 4. So here we have sine of the other angle, pi over 3. And here it was cosine of pi over 3, so now it's going to be cosine of the other angle, pi over 4. And again, we know what these values are. So sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3, again, if we're not sure, we can draw a little unit circle here, like so. And pi over 3 is this angle. So that's pi over 3, which is the same as 60 degrees. So this is going to be 1/2 comma the square root of 3 over 2. So cosine is 1/2. Cosine of pi over 3 is 1/2. Plus sine of pi over 3, which is square root of 3 over 2, that's the y-coordinate, times cosine of pi over 4, which is square root of 2 over 2. So this is going to be the square root of 2 over 4 plus the square root of 6 over 4. And combining those gives us the square root of 2 plus the square root of 6 over 4. And that's our answer. Let's do another example. Find the exact value of cosine of pi over 12. So we're going to do this one in a similar way. So we're going to start with cosine of pi over 12, and we're even going to use the same angles that we used the last time. So we're going to write pi over 12 as 4 pi over 12 minus 3 pi over 12. In the last example, we added these two angles together, but now we're computing their difference. So this is cosine of 4 pi over 12 is pi over 3. And from this, we subtract 3 pi over 12, which is pi over 4. So now we want to use a difference formula for cosine. So cosine changes the sign. So it'll be cosine of pi over 3 times cosine of pi over 4. So remember, the cosine identities start with the product of cosines. So it's cosine of a difference. So you're going to start with the product of the two cosines, and then you're going to change the sign. So here it's a minus, so now it's going to be a plus. And then it's the product of the two sines, sine of pi over 3 times sine of pi over 4. So for the cosine identities, you start with the product of the two cosines, and then you have the product of the two sines. Since it's a difference formula, cosine changes the minus to a plus. Okay, and now we just compute all of these values. So cosine of pi over 3, we just saw that that was 1/2, times cosine of pi over 4, so that's the square root of 2 over 2, plus sine of pi over 3, that's the square root of 3 over 2, times sine of pi over 4 is 1/2. So we have the square root of 2 over 4 plus the square root of, oh, sorry, this should be the square root of 2 over 2, square root of 6 over 4. And that's equal to the square root of 2 plus the square root of 6 all over 4. So once again, we've ended up with the same answer that we had before. So if we go back, we can see that we saw that sine of 7 pi over 12 is square root of 2 plus square root of 6 over 4. And also, cosine of pi over 12 is the same thing, square root of 2 plus square root of 6 over 4. Now in this case, we don't have complementary angles. So note that the first angle, which was 7 pi over 12, just wanted to go back and check. So if we start with 7 pi over 12, and we add pi over 12 to that, we don't get 90 degrees, or pi over 2. This is 8 pi over 12. And that's not the same thing as pi over 2. So these aren't complementary angles. However, 7 pi over 12 minus pi over 12 is equal to 6 pi over 12, and that is pi over 2. So it's not the case that 7 pi over 12 and pi over 12 are complementary angles. However, 7 pi over 12 and minus pi over 12 are complementary. And cosine of minus pi over 12 is the same thing as cosine of pi over 12. Because cosine is an even function. And cosine of pi over 12 is equal to sine of the complementary angle. So, or rather, cosine of minus pi over 12 is sine of the complementary angle, and we saw that that was the same thing as sine of 7 pi over 12. So again, it's no coincidence that the value that we got this time was the same as the value in the previous example. Let's do another example. Actually, let's verify a cofunction identity. We've already commented on the fact that this identity is true, but you can actually prove the cofunction identity using the sum and difference formulas. So we want to show that cosine of pi over 2 minus theta is sine of theta for any angle theta. But notice that this is the cosine of a difference of two angles. So we can just use the difference formula for cosine. So cosine of pi over 2 minus theta is equal to, so this is the cosine identity, so you start with cosine of the first angle times cosine of the second angle, and now you change the minus sign to a plus sign. Remember, the cosine identity changes the minus to a plus sign. So that becomes plus, and now it's the product of the signs. So it's sine of pi over 2 times sine of theta, like so. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So what does that tell us? That tells us that cosine of pi over 2 minus theta is equal to 0 times cosine of theta plus 1 times sine of theta. Well, 0 times anything is 0, and then 1 times sine of theta is just sine of theta. So that proves the cofunction identity for us. We've just shown that cosine of pi over 2 minus theta is equal to sine of theta. Our next example asks us to rewrite sine of x minus pi over 4 in terms of sine of x and cosine of x. So here we just want to use the difference formula for sine. So let's go ahead and do that. So sine of x minus pi over 4 is equal to, so this is a sine identity, so we'll start with sine times cosine. So it's sine of the first angle times cosine of the second angle. And sine preserves the sign, so this is a difference formula, so we end up with a minus sign. And now it's going to be sine times cosine again, but we just swap the angles. So now it's going to be sine of pi over 4 and cosine of x. So we started out with sine of x times cosine of pi over 4. So it's a sine times a cosine. And from that we're going to subtract a sine times a cosine, but we're just swapping the angles. So first it was sine of x, now it's sine of pi over 4. Cosine of pi over 4, now it's cosine of x. Okay, well, we know how to compute sine and cosine of pi over 4. So cosine of pi over 4 is the square root of 2 over 2, and sine of pi over 4 is also the square root of 2 over 2. So we end up with sine x times the square root of 2 over 2 minus the square root of 2 over 2 times cosine of x. And that's really what it's asking us for. Let's put the square root of 2 over 2 in front of sine, like so. So we've shown that sine of x minus pi over 4 is equal to the square root of 2 over 2 times sine of x minus the square root of 2 over 2 times cosine of x. And that's what we wanted to do. We wanted to write it in terms of sine of x and cosine of x, and here it is. Let's look at another example. This example wants us to do actually the opposite. Before we had a sine function and it asked us to write it in terms of sine and cosine. Here we have sine and a cosine, and we want to combine them into a single sine function. So how are we going to go about doing that? Well, actually, I'm just going to rewrite this slightly. So I'm going to write this as sine of 4x times the square root of 3 over 2 minus 1/2 times cosine of 4x. The idea here is that we want to use a sum or difference formula, but in the reverse direction of the way that we've been using it. So what I want to do is I want to write this square root of 3 over 2 as a cosine and this 1/2 as a sine. So in other words, I want to write this as sine of 4x times cosine of something, let's just call it theta, minus sine of theta times cosine of 4x. So like this, if we write it like this, it has the form of the difference formula for sine. So this would be equal to sine of 4x minus theta, for whatever theta happens to be. Because if we use the difference formula for sine on this expression, sine of 4x minus theta, we'll have sine of 4x times cosine of theta, and then this is the difference formula for sine, so we keep the sign. So sine preserves the sign, so it's still a minus. than sine of theta times cosine of 4x. So we just need to figure out what theta is in this case. Well, the idea is that you want cosine of theta to be square root of 3 over 2, and we want sine of theta to be 1/2. Let's write that out. So we want, well, let's write cosine first. We want cosine of theta to be the square root of 3 over 2, and we want sine of theta to be equal to 1/2. So if we draw our unit circle, like so, we want the x-coordinate to be square root of 3 over 2 and the y-coordinate to be 1/2. So the y-coordinate is 1/2, so it's going to look like that. Square root of 3 over 2, comma, 1/2. Now this is the 30-degree angle, or in radians, this one is pi over 6. So what that tells us is that theta is pi over 6. So our answer then is just sine of 4x minus theta, where theta is pi over 6. So this is going to be equal to, let's write it up here, we'll just write it as sine of 4x minus pi over 6. And that's our answer. Let's do another example. This time we're asked to verify an identity. We want to show that sine of x plus y over sine of x minus y is equal to tangent x plus tangent y divided by tangent x minus tangent y. So here on the left side, we have a sine of a sum, and in the denominator we have sine of a difference. So we can use the sum formula for sine in the numerator and the difference formula for sine in the denominator. And whatever we end up with, we'll see if we can make that look like what's on the right side of the equation in terms of all of these tangents. So let's do that. So we start out just by writing the left side of the equation down. Sine of x plus y divided by sine of x minus y. Now, in the numerator, we're going to use the sum formula for sine. So that's going to be sine of x times cosine of y. Sine preserves the sign, so this will be a plus. And then sine of the other angle times cosine of the other angle. And we want to divide this by sine of x minus y, so we're going to use the difference formula for sine. So this will be exactly the same, except now we'll have a minus between the terms. So it's sine of x times cosine of y minus sine of y times cosine of x. Now our objective here is to get a bunch of tangents. So tangent is sine over cosine. So for example, I want to get a tangent of x here, and I have a sine of x. So I just need to divide everything by cosine of x to get a tangent here. On the other term, this other term, we want a tangent of y, and here's a sine of y. So if I divide by cosine of y, that should give me a tangent here. So let's give that a try. Let's try dividing everything. Let's divide everything in this numerator by cosine of x, cosine of y. And if we do it in the numerator, we have to do it in the denominator too. Let me use brackets. So we're going to do that in the denominator as well. So we're going to divide the denominator by the same thing. If you divide the numerator by cosine x, cosine y, you have to divide the denominator by cosine x, cosine y. So what's that going to give us? Well, let's look at the numerator. We'll have sine x cosine y plus sine y cosine x. And we're going to divide this term by cosine x cosine y. That product. And all of this is going to be divided now by sine of x cosine y minus sine of y cosine x, and we're dividing this by the same thing, cosine x cosine y. Let's put brackets around the numerator and brackets around the denominator. Okay, our objective here is to simplify this now. So here's what I'm going to do. I'm going to just write let's just look at the numerator. So the numerator is going to be sine of x cosine of y divided by, I'm going to distribute the cosine x, cosine y in the denominator here. Cosine x, cosine y, plus sine of y, cosine of x, divided by cosine x, cosine y. And all of this is going to be divided by, let's make that a little bit, let's do this. All of that's going to be divided by this denominator. So I'm going to put that in the denominator, but again, I'm going to break it up into two. So this is sine of x cosine of y divided by cosine of x cosine of y minus sine of y cosine of x divided by cosine of x cosine of y. So what have we done here? The numerator, we just broke it apart into two terms. And the denominator, we've done the same thing. We've broken it apart into two terms. So what I want to do, just to make sure everything's clear, the numerator is in green brackets, and the denominator, let's put it in orange, like so. Okay, that's this one. That's the denominator. Now it's a matter of canceling like terms. So here's a cosine y that'll cancel with that cosine y. Here's a cosine x that will cancel with that cosine x. Here's a cosine y that will cancel with that cosine y, and a cosine x cancels with cosine x. What are we left with now? We're left with sine of x over cosine of x plus sine of y over cosine of y, and all of this is divided by sine of x over cosine of x minus sine of y over cosine of y. But sine over cosine is tangent, so this is tangent of x minus tangent of y divided by tangent of x. Well, that one's a plus. Minus tangent of y. The numerator has a plus, the denominator is the one with the minus. But this is exactly what we were trying to show. If we shrink all this down so we can fit it all onto one screen, we wanted to show that sine of x plus y divided by sine of x minus y was equal to tangent x plus tangent y divided by tangent x minus tangent y. And that's what we have here. So that verifies this identity. Now we also have sum and difference identities for tangent. And those are here. Tangent of alpha plus beta is tangent of alpha plus tangent of beta divided by 1 minus tangent alpha tangent beta. And tangent of alpha minus beta is tangent of alpha minus tangent of beta divided by 1 plus tangent alpha tangent beta. So we do have sum and difference formulas for tangent as well, but usually it's just easier to write tangent as sine over cosine and then use the sum and difference formulas for sine and cosine. But you do have these formulas available if you want them.